Coordinates of some particular points in triangles. When we have coordinates of a triangle, how to calculate circumcenter, incenter, excenter, orthocenter, and centroid. These are the things we'll look into in this particular video. And also when we have 3 points, we will try to check whether they form a triangle or not. Now, what's a centroid? It's a point of intersection of medians in a triangle where median is a line joining the midpoint of one side to the opposite vertex. Consider any triangle ABC and let D be the midpoint of side BC. Now join A to D, this gives a median. In similar way, midpoint of AC, let it be E, join B to E, that's the other one. Midpoint of AB, let it be F and join C to F, that gives the third median. Now, the point where all these three medians meet is called as a centroid and is denoted by letter G. This centroid divides the median in the ratio of 2:1. We have to consider starting from the vertex of the triangle. So AG is to GD is 2:1 when we consider the median AD. Now for this centroid, it is an internal point that divides the triangle into three parts of equal area. The triangle ABG, triangle ACG, and triangle BCG, all these three triangles will have equal area. When we have the coordinates of the vertices like this, let it be x1, y1, x2, y2, and x3, y3. The coordinates of centroid can be found using a simple formula, that is x1 plus x2 plus x3 upon 3, comma, y1 plus y2 plus y3 upon 3. This gives the centroid. The next one is incenter. Incenter is the point of intersection of internal bisectors of angles of a triangle. Now consider the triangle. For A, the angle bisector will be drawn like this. So this line will divide the angle A into exactly two halves. That is the angle bisector. Similarly, when we draw the bisectors for B and C, all the three bisectors meet at a point called as incenter and is denoted by I. Now this I is useful to draw a circle touching the sides of a triangle internally. And this I also divides the angular bisectors in different ratios. In the formula shown here, small a, small b and small c represents the length of sides. Small a represents the length of side opposite to vertex A, means length of BC side is nothing but small a. Similarly, length of AC is small b and length of AB is small c. When we have these lengths, the incenter will divide the bisector in the ratio shown here, like B plus C is to A is for angular bisector from A, and from B for that particular angular bisector will divided in the ratio of C plus A is to B, and for the angular bisector drawn from vertex C it will be divided in the ratio of A plus B is to C. Like this, from different vertices will divide the opposite side as well. Here if we consider the bisector drawn from the vertex A, it divides the side BC at D, and this ratio will be equal to the ratio of the remaining two sides. Now it's touching the side BC at point D, and the ratio of BD is to CD will be equal to AB is to AC. To find the incenter, we have a formula AX1 plus BX2 plus CX3 upon A plus B plus C, comma AY1 plus BY2 plus CY3 upon A plus B plus C, where ABC stands for the length of the sides. Circumcenter is a point of intersection of perpendicular bisectors of the sides of the triangle. For a triangle, a particular side, if we take a perpendicular bisector, means the line drawn should be perpendicular to the side and it also should pass through the midpoint of that particular line. Say for BC, if we have the midpoint, from that point we have to draw a perpendicular like this. Now it has to make 90 degrees. In a similar way, when we draw the perpendicular bisector, means passing through midpoint and perpendicular to that particular line, these all three will meet at a point called as circumcenter and is denoted by letter O. This O is useful to draw a circle passing through the vertices of the triangle. And the relation of the O with the vertices will be like OA square is equal to OB square is equal to OC square, which means OA here is the distance between point O and A. O will be equidistant from all the three vertices. Orthocenter is the point of intersection of perpendiculars drawn from vertices to the opposite side of a triangle. In the previous circumcenter, it is a perpendicular at the midpoint. When we extend that, it doesn't have to touch the opposite vertex. But here in orthocenter, it is a perpendicular to a side and it will pass through the opposite vertex as well. Now consider this triangle. If we see, we will be drawing a perpendicular from the opposite vertex. In that way, if we do for all the three sides, they meet at a point and it's called as orthocenter, denoted by H. Excenter means when we draw a circle which touches a side and the extended portions of other two sides. These circles will be exterior to the triangle. Those circles are called as X circles and the center of such a circle is called as a H center. And to calculate these excenters, we just have to use the incenter formula, but we will do a little modification depending upon the position of the X circle. Say if we are drawing a X circle opposite to vertex A, it is called as I1 minus AX1 plus BX2 plus CX3 upon minus A plus B plus C, comma minus AY1 plus BY2 plus CY3 upon minus A plus B plus C. This minus sign before A, as the formula is for this particular I1, that's the excenter opposite to vertex A. So wherever we have a small a in the formula of incenter, we'll just write minus there. That gives the x center opposite to a vertex. When the x center is opposite to the vertex B, will keep a negative sign for B, and if it is opposite to vertex C, will keep a negative sign for C in the formula. And these x centers are represented by I1, I2 and I3. From all these particular points, whatever we see for a triangle, there are few relations they hold. All the triangles are categorized as either acute, obtuse, or right angle triangle. In all those cases, centroid and incenter will always lie within the triangle. But the circumcenter and orthocenter depends upon the type of triangle. If it is an acute angle triangle, both the circumcenter and orthocenter will be inside the triangle, and for obtuse, they will be outside. For a right angle triangle, circumcenter would be the midpoint of the hypotenuse and orthocenter would be the vertex where we have the right angle. Apart from this, in an equilateral triangle, centroid, incenter, orthocenter, and circumcenter coincide, which means the values that we find, all the values will be same. They represent the same point. And orthocenter, centroid, and circumcenter for any type of triangle, say if it's not a equilateral, it could be isosceles or a scalar. In that case, they will be collinear, and the centroid divides the line joining orthocenter and circumcenter in the ratio of 2:1. In case of an isosceles triangle, all these points will lie on a line which is nothing but the line of symmetry for that triangle. Now here we have 3 points A, B, C that represent 3 different points on a coordinate plane. The first step is to identify whether they represent a triangle or not. For that, calculate the area of triangle. If it is 0, it means the points are collinear, and if there is a value for it, that just represents a triangle. First we'll do that. Now substitute the values here. Half x1, that's 2. y2 minus y3, 3 minus, if we take the minus sign inside, we'll have 3 minus root 3 plus x2, that's 4 here. y3 minus y1 plus x3 of y1 minus y2. So here this 3 and 3 will get cancelled out. This minus root 3 plus 4. When we cancel this 3 and 3 will have root 3, 4 root 3 plus 3 and minus 3 will get cancelled out. That's 0. 3 into 0 is 0. Now here these two are like minus 2 root 3 plus 4 root 3. That is nothing but 2 root 3 here. And we have half before this. So the 2 and 2 will get cancelled out and we'll have root 3 as the answer. So this means the points represent a triangle. But we can simply substitute the values in the formula. We know the formula for centroid as x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. We'll substitute the values here. This 2 plus 4 plus 3 upon 3, comma, y1 that is 3 plus y2 plus y3 upon 3. This represents the centroid for this particular triangle. Here 2 plus 4 is 6 plus 3 is 9 upon 3 is 3. 3, 3 and 3 that is 9 plus root 3 upon 3. This can also be written as 3 comma 9 upon 3 is 3 plus root 3 upon 3 gives 1 upon root 3. This is a value for the centroid. For incenter, we also have a formula. A, B, C here represent the length of sides. We'll try to find these values first. For A, that is nothing but the side BC. It's root x3 minus x1. 3 minus 4 is minus 1 whole square plus y3 minus y2. That gives root 3 whole square. This will be 2. Similarly for B, B is nothing but a distance between points A and C. Here we have 3 minus 2 whole square plus 3 plus root 3 minus 3 whole square. 3 minus 2 is 1, so 1 square. 3 and 3 will get cancelled out. Root 3 whole square is 3. This gives 2. C is nothing but distance between points A and B. We'll have under root 4 minus 2 whole square plus 3 minus 3 whole square. That gives 2 as the result. So A, B and C values we have here. Here all values are 2. They need not be the same, but here we have got same values. Now we'll try to find the incenter. I is equal to AX1, that is 2 into 2 plus BX2 plus CX3 upon A plus B plus C, comma, A y1 plus B y2 plus C y3 upon A plus B plus C, that's 6 here. I have here. To simplify this, 2 into 2 is 4, then 2 into 4 is 8, plus 2 into 3 is 6 upon 6, comma, again 2 into 3 is 6, 6 plus 6 plus 2 root 3 upon 6. Now this will be equal to 4 plus 8 is 12 plus 6 is 18 upon 6, comma, we have 1, 2, 3, 6 here, that is 18 plus 2 root 3 upon 6. Now this is equal to 18 upon 6 is 3, comma, again 18 upon 6, that is 3 plus, then we have 2 root 3 upon 6. The 6 is nothing but 2 into 3 and then 3 is again root 3 into root 3. So this 2 and 2 will get cancelled out, root 3 and root 3 will get cancelled out. We have 1 here in the numerator. This is 1 upon root 3. This is the incenter we have now. Circumcenter, to find circumcenter, we'll use this thing, that's the center is equidistant from the vertices. We have to find the distance values, equate them, and then we will get the position of circumcenter. So initially let us think this O value to be H comma K. These are the coordinates of circumcenter. To find the distance between OA square will do that. OA that we can write as H minus 2 whole square plus K minus 3 whole square is equal to OB square, that is H minus 4 whole square plus K minus 3 whole square equal to OC square, that is H minus 3 whole square plus K minus 3 plus root 3 whole square. Expand this. This will give h square minus 4h plus 4 plus k square minus 6k plus 9 equal to h square minus 8h plus 16 plus k square minus 6k plus 9 equal to h square minus 6h plus 9 plus k square minus 2k into this entire thing, 3 plus root 3, and then we'll have 3 plus root 3 whole square. First, we will try to use these two equations and see. H square will get cancelled out, k square and k square will get cancelled out. Take the h to the other side, we'll have, in this we can also cancel h square and k square. Now if we take minus ah to the other side, it will become, from these two equations, 8h minus 4h here, minus 6k, and from here we'll have minus 6k, that will become 6k when it comes to the other side of equal to. Here 4 plus 9 is 13, and then we have 16 plus 9, that is 25. When we take to the other side, it's like minus 25. From this we can write 4h, these two will get cancelled out, minus 12 equal to 0 when we consider only these two equations. Now consider these two equations, only these two. Take the 6h to the other side, it becomes 6h, and minus 8h we have already. Minus 6k is there. When we take this k value to the other side, it becomes 2k of 3 plus root 3. 16 plus 9 is 25 we have here, and the 9 to the other side is minus 9, and this to the other side will make minus 3 plus root 3 whole square equal to 0. Further simplify this, here it would be minus 2h. Here minus 6k plus 6k will get cancelled out, and then we have 2 root 3k. 25 minus 9, this will become plus 16 minus, expand this, that is like 9 plus 6 root 3 plus 3 equal to 0. This is minus 2h plus 2 root 3k. 9 plus 3 is 12. 16 minus 12 is 4. And then we have minus 6 root 3 equal to 0. Now coming to this part, if we simplify this, it will give h is equal to 3, and place that h is equal to 3 in this. 2 into h, 2 into 3 is 6, minus 6 plus 2 root 3k plus 4 minus 6 root 3 is equal to 0. Minus 6 plus 4 is minus 2, minus 6 root 3 plus 2 root 3 k equal to 0. Take these two things to the other side, then we'll have 2 root 3k is equal to 2 plus 6 root 3 k is equal to 6 root 3 upon 2 root 3 plus 2 upon 2 root 3. Now this root 3 will get cancelled. 6 can be written as 2 into 3, and 2 and 2 will get cancelled. We'll have 3 here. 2 and 2 here again, we'll have 1 upon root 3. So the circumcenter h comma can be written as 3 comma 3 plus 1 upon root 3. This is the value for the circumcenter. To find the orthocenter, we have to consider the perpendicular drawn from a vertex to the opposite side. For that, consider any two altitudes. These lines are called as altitudes, and find intersection point of those two altitudes. That we know a point, that is nothing but the vertex, and then we have to find the slope. When we have the slope of the opposite side, consider the perpendicular slope and calculate the equations. Now consider this A point, that is 2 comma 3. For that, opposite side is BC. Slope of BC can be written as 3 plus root 3 minus 3 upon 3 minus 4. These two will get cancelled out, and we'll have minus root 3 as the slope of BC. And for this, the perpendicular line will have a slope of minus 1 by slope of BC, that is equal to minus 1 upon minus root 3. This gives 1 upon root 3 as a slope. Now we have to find the equation of line passing to 2 comma 3 and with slope 1 upon root 3. It is y minus 3 is equal to 1 upon root 3 into x minus 2. On further simplifying, we'll have root 3y minus 3 root 3 is equal to x minus 2. This is nothing but x minus root 3y minus 2 plus 3 root 3 is equal to 0. This is the first altitude we have. For the second altitude, we'll take the vertex b, that is 4 comma 3, and we need the slope. Slope of AC, we'll find it out here. AC slope is 3 plus root 3 minus 3 upon 3 minus 2. 3 will get cancelled out. Root 3 upon 3 minus 2 is 1. So we'll have root 3 as the slope of AC. Then the line perpendicular to this will have minus 1 upon root 3 as the slope. So now we have the slope here. We will try to find this line as well. That is y minus 3 is equal to minus 1 upon root 3 into x minus 4. We simplify this. This is root 3y minus 3 root 3 is equal to minus x plus 4. And then if we take everything to one side, we'll have x plus root 3 minus 4 minus 3 root 3 is equal to 0. Now we use these two equations to find the point of intersection. We can write x, y1. Then under here we have to write the b values. When we take these equations are in form of ax plus by plus c equal to 0. Consider this and now take the b values, that is minus root 3 is first one and then we have root 3. Now c values, that is minus 2 plus 3 root 3 and minus 4 minus 3 root 3. Now a values, that is 1 and 1, again the b values minus root 3 and root 3. Here x upon, like cross multiplication we have to do, minus root 3 into minus 4 minus 3 root 3 minus of root 3 into minus 2 plus 3 root 3 is equal to y upon, again cross multiplication, that is minus 2 plus root 3 minus of minus 4 minus 3 root 3 is equal to 1 upon, again cross multiplication, it is root 3 plus root 3. Here we'll get x upon these two things, that is 4 root 3 minus root 3 into minus 3 root 3 will give plus 9. Minus root 3 into minus 2 is plus 2 root 3. Minus root 3 into 3 root 3 is minus 9. So 9 and 9 will get cancelled out. And these two sum up to be 6 root 3 is equal to y upon minus 2 plus 3 root 3. Minus gets inside. So plus 4 plus 3 root 3. So if we simplify this further, 4 minus 2 is 2. 3 root 3 plus 3 root 3 is 6 root 3 here, equal to 1 upon root 3 plus root 3 is 2 root 3. So x is equal to 6 root 3 upon 2 root 3. Now these two will get cancelled and here it's 3 times. So x is equal to 3. And for y it is nothing but 2 plus 6 root 3 upon 2 root 3. So this can be written as 2 upon 2 root 3 plus root 3 upon 2 root 3. 2 and 2 will get cancelled out here. It's 1 upon 3 and here these 2 will get cancelled out. And it's 3 times plus 3. This can also be written as 3 plus 1 upon root 3. Now this x and y is nothing but the value for the orthocenter, that is 3 comma 3 plus 1 upon root 3. These are the values. If we observe all the points we have obtained till now for the centroid, incenter, circumcenter and orthocenter, all the values are like 3 comma 3 plus 1 upon root 3. And all the values are same. So this triangle is equilateral triangle and so all the points are same, means they coincide with each other. How can we know it to be an equilateral triangle? By calculating the incenter, we have find the values of a, b, c, small a, small b, small c, which are nothing but the lengths of the sides and all are equal to 2. All the sides are equal, which means it's an equilateral triangle. So with that, we can validate the key point we have seen before, that is in equilateral triangle, all these points coincide with each other. Not only that, we know a centroid divides a median in the ratio of 2 is to 1. Using that, we can calculate this incenter ratios as well. Here it's B, C, and A all are 2. So it is like 2 plus 2 is to 2. This means 4 is to 2, nothing but 2 is to 1. So incenter here is dividing those angular bisectors in the ratio of 2 is to 1, which is same as the way a centroid divides, as it's equilateral and all these points coincide. In this video, we have looked into how to find the particular points in a triangle. The points are like circumcenter, centroid, incenter, and orthocenter. When we know the coordinates of a triangle, and also how to check whether the 3 points represent a triangle or not. For that, we have used the area of triangle. In the next section, we'll see how to find these points when we have the equations of the sides of a triangle.